Today we are going to talk about the Drake equation, which the Drake equation is basically a theoretical equation which basically allows you to sort of think about whether there could be extraterrestrial life. In some ways it's supposed to help you answer the question, does extraterrestrial life exist? The summary of this video is basically the Drake equation says definitely life exists, and it also says definitely life does not exist, except here on Earth. And so we'll go through how you can get extremes, both way too positive and way too negative on the end of the spectrum there. So what is the Drake equation? Well, so this is the Drake equation here. So it is basically just a bunch of multiplications, some numbers just multiplied together. It is super simple. You don't need any calculus or anything like that at all. It's literally just like a probability equation. So n is the number of civilizations in our galaxy that we should be able to detect. So how many civilizations could exist that we can actually have the possibility of hearing. Right now it's 0 because we haven't detected any, but the question is are we on the verge of detecting hundreds of them or anything? That's what this is supposed to talk about. And this is a rate equation in some ways, and so it's sort of looking at the potential for civilizations that exist over some amount of time. And so R is actually the rate of stellar formation, so how many stars form each year. And so it's not the total number of stars that exist in the galaxy, but the number of stars that actually form each year. FP is the fraction of stars with planets. NE is the number of planets in a solar system that are in the habitable zone, or number of bodies that actually could potentially sustain life. FL is the fraction of planets in which life actually appears, so any form of life whatsoever. FI is the fraction of life-bearing planets that actually produce intelligent life. So if those planets actually have life, does that life ever get to be intelligent? FC is the fraction of civilizations that produce detectable signals. So, you could argue that chimpanzees and dolphins and stuff are sort of intelligent life, but they're incapable of producing detectable signals. And so there could be a planet just over the horizon that has dolphins and chimpanzees on it or something, but we can't actually hear them because they're not saying anything. So it's not necessarily that there are planets that have life. This doesn't say anything really about that. It says whether there is detectable life. And then L is the length of time that civilizations can send these detectable signals. So if the civilization is actually capable of sending signals, how long does that civilization exist? All right, so let's go into more details about each of these. Rx is the rate of star formation, so basically how many stars are coming online each year. There are roughly 250 billion stars in our galaxy right now, and the rate of new star formation is roughly 1 to 3 stars per year. So new stars are forming all the time. New planets are forming around those all the time. And this doesn't necessarily say that this year there will be a star that is formed with a planet that has intelligent life. This is saying N billion years ago there were stars that were forming, roughly one a year or something like that. Of those, how many actually were producing planets and intelligent life and stuff like that. FP is the fraction of stars that have planets. And so up until a few years ago, this was really no one really knew the answer to this because we couldn't see planets around stars. But now with Kepler and other telescopes, we can actually see planets going around stars. And so it was originally thought to be maybe 20 to 50% of the stars have planets, but now it's basically been shown that it's pretty close to 100% of stars have planets. Then NE is the average number of planets in the habitable zone of the star. Not necessarily actually in the habitable zone, I sort of put that there, but it's technically the number of bodies that are capable of sustaining life. For us, that could be like Titan, could technically sustain life. Europa could technically sustain life. Does it? We don't really know, but it could happen. And so we actually have a large number of these bodies in our solar system that could potentially sustain life. This was originally thought to be between 1 and 5 planets around the stars, and some believe that it could be roughly 3 to 5 now. And it's really hard to tell because the telescopes that we have that can detect stars going around, planets going around stars, can't really detect small planets that are in the habitable zone. They're really meant to detect larger planets that are much closer to the sun, or the star. And so we're going to nail this down pretty soon with newer and newer telescopes that are being launched. We can't really address this right now, but we can estimate. Okay, so FL is the fraction of planets that actually develop life. That was originally thought to be close to about 100%. But we really have no basis for estimating this whatsoever. We basically say things like, well, Earth developed life, therefore every planet in the habitable zone must develop life. Okay, well, then you have to ask, why is there no life on Mars, Titan, or Europa? And you really can't even say whether there was or is life on Mars, Titan, or Europa. We just don't know. And so the range of this is basically almost anything from 1% of planets in the habitable zone develop life to 100%. We have no real idea, and it's completely a guess at this point. Okay, then the fraction of life that becomes intelligent. Originally, people thought that this was very high, so near 100%. Basically, like, if life exists, it will become intelligent. It will become more and more complex with time. It will eventually, all civilizations lead to people and and things that can be very, very complicated. But, that's pretty biased towards, like, thinking, that we're, like, the best. And we're naturally, like, what everything is made to come to. Life on Earth remained a single-cell organism for, like, 1 billion years. So really, we have no idea how quickly life can evolve, whether it does evolve to be intelligent or not. So this number could actually be really, really, really small. So you could give values of like 1% of all life becomes intelligent eventually, and or 0.1%, no real idea. FC is the fractions of intelligent civilizations capable of sending signals to others. So basically, like, you have become an intelligent civilization, so like Neanderthals or something like that, they're sort of intelligent, but they are incapable of sending signals to other planets. It's very hard to estimate this, and the funny thing is that we actually don't have this capability right now ourselves. So even if we think that it's a large number, like, there's no basis for it being a large number, because we can't even do this. So, for example, if like we went to another star and we took the Earth's largest telescopes or Earth's largest radios and sent the signals back to Earth, and we used our largest telescopes on Earth, we couldn't detect those signals. So what does that really say? It tells us that we have no real idea what we're talking about. We're close to this. We're pretty close. We just need, maybe 5 times as much power and maybe 5 times as much receiving signal sensitivity. We're close. And so we could say like maybe 1% of civilized, quote, civilized civilizations could produce signals that we could actually hear. If the Romans existed somewhere else, we definitely couldn't hear them. All right. L is then the length of time that civilizations can send detectable signals. So once they reach the technology level where they can actually like send signals, like how long do they last? We have no idea. Once again, we have been around for, a couple thousand years, but we have had the technology to send signals out into space for maybe 50 years. Some people have done some estimations and shown that countries tend to last for about 300 to 400 years. Of the major countries that have existed over the last few millennia, they last for about 300-400 years on average, and then they die off. That doesn't mean that the technology that they gained is lost or anything, but that's sort of a lower bounds of like how long, quote, civilizations last if you count a country as civilization. It was originally thought to be 1,000 to 100 million years. So, some people were pretty pessimistic about it. Like humans will exist for about 1,000 years and then they were just going to kill themselves off, to like, if we can survive coronavirus, we're going to live to 100 million years old. That's sort of optimistic, but who really knows? Yeah, so how long do you think that humans will exist? And then the question really is, like, do civilizations actually survive or do they self-destruct? And so a wild guess is like 1,000 years to 100,000 years. That's really the range. No one really knows. So if we do these calculations, so this once again is the Drake equation here. If you are very pessimistic about this, then you can set the numbers like Rx is equal to 1, Fp is equal to 0.2, Ne is equal to 1, blah, blah, blah. You set all those numbers. Civilizations only last for 1,000 years. So you multiply all those numbers together and you get that the number of civilizations that exist in the galaxy that we can communicate with are roughly 2 times 10 to the minus 5th. This has to be over 1 in order for us to actually be able to communicate with anybody, anything. And so having 2 times 10 to the minus 5th means that we are completely alone, that there are no civilizations out there whatsoever that we can communicate with. That's sad, but this is sort of like the we're so incredibly special because we were made to be special and blah, blah, blah type of theory of the universe, like the universe is made for us. If you're more optimistic, I guess it depends on what your definition of optimism and pessimism is too, but if you are optimistic, then you can take numbers which actually are not like super different, except for L is pretty different, but you multiply all of these numbers together and you can get that there are 15 million different civilizations out there in the galaxy, and the galaxy is really teeming with life. Like, life is everywhere. That brings up the idea of what's called the Fermi Paradox, because like if there is life everywhere, then why haven't we observed it? And so Fermi brought this up, and this has been discussed lots and lots and lots. And there are all sorts of ideas about like, if there's life out there, why haven't we observed it? So this is these are some of the ideas. Fi is the number or the percentage, the probability really of like life becoming intelligent. Life can exist all over the place, but intelligent life is actually rare. So like Mars might have life, but it's going to be single cell life and, technically life, not intelligent life. FC could also be very small. So you could argue that there is intelligent life out there, but it just doesn't have the ability to communicate. So like the Romans couldn't communicate. There is intelligent life there in Rome, but can't communicate. There could be a lot of civilizations out there that have reached that stage, and we just can't communicate with them. L could also be quite small, so intelligent life could be quite unstable, and it might kill itself off. So, we reach to the point where we can do genetic manipulation and then we just destroy society. Or we reach to the point where we discover nuclear power and we destroy society. There are all sorts of these technological things, leaps that you can go to that are potentially devastating for civilizations. And it could be that that's what happens to many civilizations. There is a sci-fi trope that basically, like, there is an agent, some sort of agent out there that, like, when you send a signal that is large enough out into the void of space, they, like, come and find you and destroy you. So that's a science fiction trope. There are lots of movies out there that go into that, lots of books that go into that. Like lots of books where people find like dead civilizations and stuff. There's also this idea of like this great filter. So basically as you walk up the Drake equation, like as you go to these numbers, they are larger and larger and larger, or they are large, but then at some point they become very, very small. And so then you just can't get beyond that. And that's one idea. That's basically the end of the video, but I just wanted to have some sort of note on communication. There are different stories and stuff that basically talk about, like, back in World War II or before World War II, we started sending TV signals out to the great void of space, and like that is a communication. But it's really, 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 really hard to actually communicate between star systems. Signals fall off as 1 over r squared, and the distance between stars is really, 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 really large. And so the signals fall off really dramatically. Even by the time you're out to like Pluto, they're really small. The other issue is that you're competing with the sun. Like when you look from another star, the Earth looks very much like the sun. Like it is right next to the sun. And so the sun is a gigantic noise generator. It's generating all sorts of radio frequency noise. And the signals that we're sending out are tiny, tiny, tiny compared to the sun's signals. And so, imagine like you're trying to talk at a party where like the music is super, super, super loud. You can't hear anybody when you're talking at a party where the noise is very, very, very loud. That's basically what's happening. The sun is very, 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 it's a party. The sun is a party. And we're trying to like yell over that party noise, and it's very hard for other people to hear, or other civilizations to hear us. And it's very hard for us to hear other civilizations, if those exist. So another civilization, really 1 star over even, like the closest star, could be yelling, here we are, here we are. If they're the same type of civilization as we are, like there's no way that we could hear them. Very sad. Okay, so the conclusion really to this whole thing is like, is there life out there? The Drake equation says definitely yes and definitely no. All right, thank you very much.